Hi everyone. This is the second series of regression for prediction, and here I'm using a different data set, which is a hospital data, and where I have mentioned all the details with respect to the data and its actually variable description. Here, if you see some of the important characteristics which is mentioned about patient characteristics like age, gender, marital status, key complaints code. Since it's a primarily hospital data, majority of the information afterwards contains their data with respect to their medical records and all. So these are the information given. And in this data sheet, we have information with respect to uh, a raw data. Raw data is nothing but uncleaned, pure data which I received, which we received from this particular uh, case. And this, if you see the second sheet, which is a modified sheet, a much modified, is actually the modified sheet. And so what I'm going to do, I'm going to use this data for regression. And here I just want to use total cost as the dependent variable here. If you see the last column, total cost to the hospital, that is going to be your dependent. I just want to predict the cost, the patient cost, so especially surgery cost with respect to the other characteristics or features. Let me read the data first. I'm just going to use the clipboard function. Let me get that data. I'm just using the modified data. So I'll come back here and let me read the data. And I'm just typing here something, read the data. And I just use read.csv. I'm just using clipboard. I just already copied my data. Separator is equal to tab, header is equal to true. Yes, I read the data. It consists of 248 observation and 51 variables or features. So the first thing is the data. If you see some of the columns here, the columns, when I read the data at that time itself, it got some kind of space in between. That's the reason it replaced with dots. But anyway, I just need the column heading cleaning. And let me do column heading cleaning and use the library uh, janitor. Let me use a janitor, and using janitor I read the data. I use a function clean names, and I use the data name data. You can see that it got cleaned. If you see here, so here, and if you see the categorical variable female, and that is actually dummy coded, that is the female is nothing but the dummy coded feature of gender, something like marital status is again dummy coded to unmarried. There are some unnecessary columns out there, right? Unnecessary in the sense, it's already dummy coded data. That's the reason I need to remove this original column from the data set. And I'm not actually doing the dummy coding here because the data itself is available in the form of coded and dummy coded one, and therefore I'm not going to use dummy coding. And I'm straight away looking at the quarter sheet, but I'm just removing the original columns out of it. Let me go back and just select or drop unnecessary columns from the data. Let me make it data something cleaned or something like that. So in the data clean I just want to delete some of the columns, like column number 1 anyway I don't need, and column number 3, and column number 5 because it's already dummy coded here, column number 135. Then if you look at 7, and I have, if you see afterwards, and 27, then I have mode of arrival. It's already coded in the form of ambulance. Mode of arrival I don't need. And then 40, and this is mode of arrival is 37, then 40, then just look at this 40. I want to drop it here. 42, and again that ln total cost, which is nothing but transformed dependent variable. I don't need 45 here. I have 45, and also look at the columns here. This 49. Okay, let me delete all this. And it is a function of data. I just go back all read all except 1 comma 3 comma 5 comma 7 27 37 40 42 and 45 and 49. Right, so 1 3 5 7 27 37 and 40 42 45 49, and let me delete that. So if you look at here, there are 41 variables here, and let me look at some of the columns again. All right, okay, we got some of the columns here. Okay, fine, let me proceed here and let me look at the missing data, check the missing data, and I'll use summary, and my data is cleaned. Also, I look at sum is.na of my data underscore cleaned. Both I'll print, I'll see around 94. It's too much. So 248 observation, 98. And if you start dropping this rows, then it will lose very relevant. So many NAs here. Look at 13 here. Then we have here NAs 23. So many, right? We have NAs with respect to BP high, and we have NAs with the BP low. We have NAs with respect to urea, HP, and we have creatinine. So many, right? Is it so many? These are the columns which we got NA. So let me do one thing. That's what totally we have. Let me do something. I can't delete that, so that I will. What I do, I will apply multiple imputation, and where we are trying to apply multiple imputation because we are not ready to delete the rows, because if you start deleting rows we will get less number of observation. I'm just using multiple imputation there. I need a package here for that. The package name is mice. This is already installed my system, so let me do one thing. So I use the word imputed. I just use mice, and mice means, so it's asking your input data, then m is equal to the number of imputed sets you need, and the method you can mention pmm, and c it is 1 2 3 4. Okay, so my data name is data cleaned, and m, that is how many imputed set I need. So I create 5 imputed sets, and I'll use the average of all thus as my final data. Then m is equal to 5, that I use method is equal to pmm, that is me matching. Then I say seed is equal to 1 2 3 4 in order to replicate things. Okay, so let's see. Yes, so we have 1 2 3 4 5 variables I used to impute. Let me create final data is equal to, use the word complete is from mice, and I use the imputed set here. So I'll use my final data. If you see your final data, it no missing, and I can check the missing data right now if you want. And let me look at sum is dot na of final underscore data. You can see there is zero missing here. Missing is gone. So let me do one thing here. uh, Split the data into train and test. So I just showed sometime before that, how do we split the data. So I use index is equal to sample function, and I use n row of my final underscore data, and I just use 80% of n row of final underscore data, call it as index here. Then I'll create training out of it. So then I'll create my final underscore data. I'll create my index with all columns. So you got training 198, test is nothing but final underscore data. Then I have minus index, that is what is left in your training data, which would be the test data. So you can see 50 observations there in test data. Yes, let us proceed. We created test and train data. So let us build the model, that is regression model. So then let me use name as model. I use lm function. Before that, I just want to see my training data. My dependent variable is going to be total cost to hospital, total underscore cost underscore to underscore hospital. So I say total underscore to underscore cost underscore hospital. I believe it's right. Data is equal to training. Let me try and see. Yes, hospital. Spelling mistake, I believe. Let's try. Uh, total cost. Total cost to hospital. Let's see. Total not okay. Cost underscore to underscore hospital. Yeah. So I'm able to get. Before that, what I do, I just use options hyphen is equal to 10, and I make the summary, and let me print the model. So you can see you got multiple r square, and here I just forget again one thing, that is nothing but setting the seed here. Let me do one thing, set dot seed, this for replication purpose, and run the model using that. Okay, fine. 87. So okay, fine. So let me do one thing before going further. I apply the stepwise regression not to clean some of the unnecessary variables here. So all the variables are included, many variables are insignificant, and let us do one thing too, and stepwise regression to get um, variables or features which is most important in predicting. Okay, what I do, I'll just model, or I would say step model, so that I can understand. I use a function step of my model, and I just mentioned trace is equal to 0, so that will not print the stepwise results, and the default stepwise regression is backward. And let me print the summary of step model, and you can see the regression. So you have only relevant variables here in this particular model, and you can understand what are the variables here. And let me proceed in terms of checking the outliers. Check the outliers of this regression equation. Specifically, I can check the outlier in my residuals. If residual value is extremely high, I can say there is an outlier. So what I do, I just use something called as training. I just call it as, I add something called as residual is equal to, then I just mention step underscore model. I'll say dollar residuals, and I have added the residuals here. I'll check is any outlays are there. Oh, I haven't. Oh, that is test. Okay, so let's check here. There is a residual here. I can check the residuals are extremely high or low, and I can use IQR based approach. It requires that Q1, and I quantile. I use training dollar residual, then I p is equal to 0.25 is Q1, right? So I apply that and I just make it Q3. That is nothing but quantile. I'll just copy paste here. I'll make it 7.5 and I run it, and here I use IQR, then I use a function IQR. I just use training dollar residual as my IQR. So you can see it here. Now I'll create min value is nothing but Q1 minus 1.5 times IQR. Max value here is say Q3 plus 1.5 times IQR. Got min and max. Let me execute the library dplyr so that I can filter. So dplyr. So let me use training filtered. I can is equal to, because I would say in this case I can rather training no out, that's better word. Okay, I can detect. I use the function, it's a function of training, then I use percentage greater than percentage, and then I use a function filter, then I use residual, then I say residual less than or equal to Q1, and residual will be Q3 less than or equal to Q3, and residual greater than or equal to Q1. Not Q1, right? Is it? We need to say it will be residual greater than min, and here residual less than or equal to max. So it will be no outlier. So it's a problem. Yeah. So training no outlier. So you can see the data. And let me implement one more thing, and I just want to delete use percentage greater than percentage, and I say select function select, I use minus residual here, so that that column will be dropped from my training data. If you see the training 187 observation, previously if you look at the training 198. So yeah, we have the data without outlier, and let me run the revised model without outlier, and then I use model final. Let's check. I'll make it model final. I use lm function, then total cost to hospital, then regressed on data is equal to training, no out. So let me spelling mistake. Yes, I use step of, then model final. I just use step. I use the function step of model underscore final, then trace is equal to 0. Okay, I'll print the summary model underscore final underscore step. That is, you can see that R score is equal to 0.98. You can see this is actually the result with no outlier. So these are the important predictors, and you can see the influence. This is what the final model we got. Let me check the multicollinearity. Check the multicollinearity. Check multicollinearity problem. So I have a package. I need a package called as car. I use VIF function, so I'll say car. Let's print the results. Library car. Okay, we have not car, VIF car. So it'll be model name we need to mention. So I just made a mistake here. So let me do one thing. I just do it here. Yes, if you see. So we need to check whether any VIF value greater than 5 in absolute value or not. None of them, even though some of them are in threshold limit, but it's not. There's no problem, fine. It's done actually. It's almost, the model is ready. So what we can do, we can predict test data and calculate predictive accuracy of the model. So my model is, then I can say predicted, PREDICT predicted. I can say predict function. So I can use model underscore final underscore step is my model. New data is equal to what? Test data. So I got the predicted value here. So I can check and estimate MAP or RMC. So I need the package metrics, and MAP first I'll calculate. I use the function MAP. So I use test data dollar total cost to hospital comma predicted is your. So you can print MAP. I'll get the value 18. So I can calculate accuracy. So it's nothing but 1 minus MAP, and you can print the result here. It's almost 81%, almost 82% accuracy. So let me look at RMSC. I can use RMSC, so I can use the same functions here. So I can then RMSC values here. So I can use this MAP or RMSC value in order to understand the accuracy. This could be compared across different algorithms, and so that whenever we run different algorithm, whichever algorithm gives us lowest RMSC or MAP, that'll be used. But as of now, we can say that looking at MAP, 81% accuracy is there in terms of predicting total cost of hospital. And the final model we developed is model final step. That's it. Thank you.